Good morning, folks. Welcome to Earth Science. Nice morning. So, what I wanted to talk about as I sit here on this planet in my backyard, I do not feel like I'm moving. So it's no surprise that early in human society, early in human science, the assumption was that we weren't, because it doesn't feel like it. I mean, you're sitting on Earth right now. Do you feel like you're moving? Unless you're watching this in the car, then you are, right? We're about to have sunrise over here in the east. The assumption was that, okay, well, this planet then, since I don't feel like I'm moving, must be sitting still, and the sun goes around us every day. It makes this little bit, goes back there and comes back down. Same with the moon. I don't know if you can see the moon behind me. There it is. So what I want to get through today are the ways in which we figured out that we actually, we are indeed moving. And there's actually two things that we got to do with that. One is that we got to figure out how did we know that we are spinning or rotating, and the other is how do we know that we are revolving around. If you've heard these terms before, you probably have. They call the Earth-centered model geocentric, the geocentric model of the solar system, which turned out to be false. And eventually, the heliocentric would be the one that sun-centered, helios for sun, sun-centered model of the solar system. So the first fellow to do this came up with this contraption. I don't know if I can turn my phone around, I guess not. Called Foucault's Pendulum. So it's much fancier than my son's Halloween bucket, a rope, and a swing set, right? So if Foucault did this, here's what he needed. First off, this swivel up here would have to be more like a fishing swivel. This one likes to swing this way, does not like swinging that way so much. Got to get rid of that. It has to be a swivel that can go all 360 degrees. This is just some crappy leftover rope from my garage. Got to be more than that, and it has to be much longer. When this fella did this, his name is Foucault. They call this thing Foucault's Pendulum. When he did this, he did it from like through a church steeple, so that it was really, really high. Now I'm going to post some videos today where you can see these in action in different museums. There's a Chicago, I think, is the one that I put on the that I have a good video of on YouTube. I've seen one in Philly in museums, but they got to be like 3 stories high, so you need a pretty big space to do it. And then they use a really thin metal cable, and then they use a big heavy metal ball, not just a plastic Halloween bucket filled with rocks. But hey, so here's what the deal would be. Now also they've got to be really careful when they let go, because if when they let go of it they like accidentally, whoops, that was being exaggerative, but if they accidentally push it to the side a bit, then that's going to cancel out the effects of this thing actually working. So what they do is they tie a string to the wall so that it's hanging, and they leave it there so that it like stops its rocking over, just leave it there for a day. And then they take a match, because even if they cut it with scissors, maybe you shove it a little bit and that screws it up, right? So they take a match and they burn the string off, and then they let it go. Now it's not going to work on my swing set here, and I'm not going to stand here for long enough. But what they see happen throughout the course of the day is that this pendulum that maintains its swing actually ends up looking like it moves around the room. And what they'll do is they'll set up a whole bunch of little pegs on the floor so that it can knock them over. And again, you'll see that on the YouTube video. And what this showed Foucault, showed humans, was that the Earth was spinning. And this is kind of complicated. So if you want to picture it's like this Earth is like spinning underneath this plane in space, like that this keeps on going, that might be the easiest way to picture it. And then the face of the Earth, as we spin towards the east, that way, the face of the Earth like spins underneath this thing, so that if I came back in a couple of hours and this was a proper setup, it'd be swinging more like this way. Well, so another fault, you can't have those posts there, right? And then if I came back like a quarter of the day later, maybe this way, this will solve my post problem. Okay. So it showed. Now I'm gonna show you some other things, like with Coriolis force and how that can shift the direction of this thing, but that's the basic. So, and then this is another one of these things where, I'm trying to take it easy on you. I'd like you to explain it to me today in today's classwork a little bit, just what Foucault's pendulum is. But it's another one of these things like on the Regents where They're not going to make you get into the physics of it. All they ever do, it's just like back in the day. So let's review. Back when we did, how do we know that there was a Big Bang? There was those two pieces of evidence. Do you remember those? I'm pausing deliberately. So if you're remembering that there was redshift showing us an expanding universe, and cosmic background radiation showing us that leftover energy from the Big Bang, then you got it, right? So that's all the regions will do. And if you followed through on the questions on those, that's all they really ask, you know. So this will be like that situation. Today is going to be, how do we know that the Earth rotates? Foucault's pendulum. That's it. How do we know that the Earth revolves? That's going to be a separate video, but you'll figure it out. Okay. Yeah. So happy November. It's quite going to be a warm one today. I have an outside thing I'd like you to do if the clouds stay away too. But I gotta go get a golf ball first. We'll see you guys soon. Take care.